Hey everyone, ready for another deep dive?
Absolutely. Always ready to dive deep.
Great. Well, today we're going to be looking into the future of black hole imaging.
Sounds fascinating.
It is. You sent in an article, Illuminating the Abyss, is that right?
That's the one.
Awesome. And a couple of scientific papers too, all about how scientists might be able to capture an image of a photon ring for the first time.
I'm excited to dig into those. Photon rings are really the holy grail of black hole imaging.
Yeah, I mean, just imagine actually seeing the edge of a black hole.
It's mind-boggling.
Yeah, totally. So I guess to start, I mean, everyone remembers those incredible images of the M87 black hole, right?
Oh, yeah, back in 2019 and 2021. Those were groundbreaking.
Totally. Those were made possible by the Event Horizon Telescope, the EHT.
Which is essentially a network of telescopes all around the world, all working together.
Right, to basically create this like virtual Earth-size telescope.
Yeah, it's pretty wild.
It is. But even with all that power, we're still pretty limited in what we can see.
That's true. It's like, imagine trying to see a dime in Los Angeles from New York City.
Oh, wow. Yeah, that puts it in perspective.
And then on top of that, you've got Earth's atmosphere distorting everything.
Right. So it's a lot to overcome.
Definitely. So if we really want to see a photon ring...
Yeah, that ring of light that orbits a black hole before disappearing into it.
Right, before it crosses the event horizon. We're going to need a lot more power and a lot more clarity.
And that's where this Black Hole Explorer mission comes in, right? BHEX.
Exactly. BHEX is a proposed space telescope. It would join the EHT network, giving us a telescope that's, well, bigger than our planet, and it wouldn't have to deal with the atmosphere.
That's amazing.
It is. But there is a challenge. Imagine the amount of data a space telescope like that would generate.
Yeah, I bet it'd be a ton.
It's massive. All that data needs to be sent back to Earth somehow. That's a huge hurdle.
Okay, I can see how that would be a problem. So what are we going to do? Send astronauts up there with a giant flash drive?
Not quite. This is where TBIRD comes in.
TBIRD, what is that? Some kind of super fast space pigeon?
I wish. TBIRD stands for Terabyte Infrared Delivery.
Okay.
It's a laser communication system.
So using lasers to transmit data.
Exactly. And we're talking seriously fast speeds here. TBIRD has already achieved 200 gigabits per second.
Wow. How fast is that in normal terms?
Think about downloading a whole movie in like less than a second.
Wow, that's incredible.
It is.
But wait, wasn't TBIRD originally designed for something else?
Yeah, it was initially meant for a different mission, but it turns out its capabilities are just perfect for BHEX.
Wow, that's lucky.
It really is.
But how would they adapt something designed for like low Earth orbit to work for a space telescope that's way farther out?
Well, they have to make some tweaks. For one, they need to boost the signal strength so it can reach those distances, kind of like shouting louder so someone farther away can hear you. And they also need to make the system more reliable because we really don't want to lose any of that precious data during transmission.
That makes sense.
And lastly, they're changing how the data is sent.
Right.
Instead of sending it all at once in a big burst, they'll be streaming it continuously.
Yeah.
More like how your internet works at home.
Okay, that makes sense.
Yeah.
So we've got this powerful Earth-based telescope network. We've got this space telescope in the works. And then we've got TBRD to beam all that data back home at like warp speed.
Yeah, it's shaping up to be something truly groundbreaking.
It sounds like we're on the verge of something huge.
Absolutely, we are. But before we get too caught up in all the tech stuff,
Right.
we should remember why this is all so important in the first place. We're not just chasing pretty pictures here. These images, they have the potential to help us understand some of the most fundamental mysteries of the universe.
I mean, that's what it's all about, right?
Exactly.
So we're talking about like unlocking some of the universe's deepest secrets, huh?
We are.
Can you give us like some specifics? What are scientists hoping to learn from, actually studying this photon ring?
Well, one of the biggest things is being able to test Einstein's theory of general relativity.
Okay.
But in the most extreme environment you can possibly imagine, at the very edge of a black hole.
Whoa, yeah, that's a pretty intense test.
It really is. See, the photon ring, it's like a cosmic fingerprint
Oh, okay.
of a black hole's gravity. And Einstein's theory, it predicts what this ring should look like. So if what we see matches up with those predictions,
Okay.
it just solidifies his theory even further. But if it doesn't...
Hold on. Are you saying this photon ring could actually like upend our understanding of gravity, like everything we know?
It's possible. Even the slightest deviation from Einstein's predictions could suggest that there's something else going on, some new physics at play. Maybe even new particles that we haven't discovered yet.
That's incredible to think about. And this all comes down to being able to see this ring clearly, which I guess brings us back to TBIRD and all that data it has to send back.
Exactly. We're talking about combining data from telescopes all across Earth and this one in space, creating this virtual telescope with just incredible resolution. And TBRD, with its speed, it makes it possible to actually deal with all that information.
Wow. It's amazing how this technology that wasn't even designed for this could be the key to all of this, to understanding these huge mysteries. It's like being in the right place at the right time, huh?
It really is.
But I have to ask, I mean, what else could we use this laser communication for? It sounds like it has potential way beyond just black holes.
Absolutely. Think about high-definition video feeds from Mars rovers, practically in real time.
Yeah.
Or crystal clear communication with astronauts, like orbiting Jupiter.
Wow.
We could even have like an interplanetary internet, you know?
An interplanetary internet. That sounds like science fiction.
I know. It's pretty mind-blowing. But let's bring it back to the black holes for a second.
Okay.
You mentioned earlier that this photon ring could help us understand the turbulence of gas falling into a black hole.
Yeah, I was a little confused about that. How does a ring of light tell us anything about gas?
It's all about the patterns. As this gas spirals into a black hole, it gets superheated.
Yeah.
It gets turbulent.
Right.
Imagine water swirling down a drain. But on a cosmic scale, and this creates these complex patterns in the light that escapes. And those patterns, they're imprinted on the photon ring.
So scientists can like decode those patterns, like read a cosmic weather report or something.
That's a great analogy.
Okay.
By analyzing those patterns, we can learn about how black holes, how they accrete matter, how they grow, and even how they influence the galaxies around them.
Wow, that's amazing. And what about those, those powerful jets of energy that shoot out of some black holes?
Oh, yeah.
I remember seeing images of those. They're incredible.
They are. And we're still not entirely sure where all that energy comes from. I mean, the M87 black hole, it's got a jet that stretches for thousands of light years.
Wow, yeah.
And the photon ring, it could actually help us pinpoint the exact spot where that jet comes from.
Uh-huh.
And give us clues about how it's powered. Like imagine tracing a river back to its source to understand where the water's coming from.
Okay, that makes sense.
It's kind of like that.
So this photon ring, it really does feel like the key to unlocking so many mysteries about black holes. It's incredible. I mean, it's amazing to think that something as, seemingly simple as a ring of light could hold so many secrets.
Right.
Like we saw that first blurry image of a black hole. It was a huge accomplishment.
Yeah.
But now, talking about potentially seeing this crisp, clear photon ring, it feels like we're on the verge of this whole new era of understanding these mysterious objects.
It really does feel like that.
And it's thanks to all the hard work of these scientists and engineers, who've spent, decades developing this technology to make this all possible.
Yeah, absolutely.
I mean, from these theoretical predictions to blurry images to potentially these crystal clear views, it's a pretty inspiring journey.
It is.
And it's not just about black holes. I mean, this laser communication technology has the potential to revolutionize how we explore the entire universe.
Yeah, think about it.
Yeah.
Like, what if we could get high-definition video feeds from a probe exploring, like, the icy plumes of Saturn's moon, Enceladus?
Whoa.
Or have, real-time conversations with astronauts orbiting Jupiter?
That's incredible.
I know. It's amazing.
It sounds like something straight out of a science fiction movie.
It does.
Interplanetary internet, high-def video from other worlds, instant communication across these vast distances.
Yeah.
It's almost hard to, wrap my head around.
I know.
But out of everything we've talked about today, what stands out to you as the most exciting aspect?
For me, it's got to be the potential to, push the boundaries of what we know,
Yeah.
Einstein's theory of general relativity, it's been super successful in explaining how gravity works,
Mm-hmm.
but we've never been able to test it in an environment as extreme as a black hole.
Right.
So observing this photon ring, it could be the ultimate test.
So if what we see matches his predictions, it means what his theory holds up, even in these crazy extreme conditions.
Exactly.
It'd be another win for Einstein.
Totally.
Yeah, and further confirmation of how we understand gravity, right?
Yeah.
But what if it doesn't match?
Right.
What if we find something unexpected?
Well, that's what makes this so exciting, right? It has the potential to just completely change how we understand the universe.
Whoa, yeah, that's huge.
Right? Even the slightest deviation from Einstein's predictions
Mm-hmm.
could point to New physics, new theories, maybe even, like you said, new particles that we haven't discovered yet.
It's mind-boggling to think about the implications of all that.
It is.
But even if Einstein's theory passes this ultimate test, I mean, the photon ring still has a lot to tell us, right?
Absolutely. The details within that ring, like the shape, the brightness, the patterns, all of that can give us information about the black hole itself, its surroundings, and the processes happening around it.
It's like we're learning to read a whole new language, a language spoken by the universe itself.
Yeah, and remember, we're still really early on in this whole journey.
Yeah.
Like, we've gone from these blurry shadows to,
Yeah.
the potential for clear images. Who knows what the future holds,
It's true. It's like we've been given this new set of eyes to see the universe.
It is.
And it just makes you wonder what other seemingly impossible things we might be able to accomplish with technologies like this,
That's the beauty of science, right?
Yeah.
It's this constant exploration, this journey of discovery that just never ends.
Yeah.
And every new discovery just opens up more questions and more possibilities.
It's so exciting.
Yeah.
Well, we've definitely explored a lot today.
Yeah, we have.
We've peered into the depths of a black hole. We've learned about the cutting edge of imaging technology,
Yeah.
and we even glimpsed the transformative potential of laser communication.
We did.
It's been quite a deep dive.
Absolutely.
Yeah, it has.
And I hope you've come away from this with a sense of awe and wonder about the universe, and maybe even a little bit of excitement about, the incredible things we might discover in the years to come.
Oh, for sure. I mean, I'm walking away with more questions than I started with, so that's got to be good.
That's always good.
Yeah, definitely.
That's how you know you're learning.
All right. Well, thanks for joining us on this deep dive.
Thanks for having me.
Absolutely. Until next time, keep exploring, keep questioning, and never stop learning.
Couldn't agree more.